Hi, so I'm Paul, and in this video, I will do a presentation about this rescue robot right here. It will be a complete presentation, include two parts. The first one is explaining everything behind the code and the hardware and the software, like everything behind this robot. And then the second thing is the second part is I will show some demo videos of how's the robots in action. I will now explain all of the codes behind this project. To begin with, we have two separate processors in here. First one is the Raspberry Pi and the second one is the Arduino Mega in here. So briefly describe about the hardware is that I have the Raspberry Pi this is connect to a power bank, but currently it is connect to a stable power source because my power bank is currently broken down. And then the HDMI cable connect to this screen right here just to show you the code. We can leave it unplugged and connect to a VNC server to observe from distance. And then for the USB port, the one in here is the mouse and keyboard USB. And then this one right here is the webcam USB. And then this one right here is the cable that connects straight into this Arduino Mega inside the MBOT. So those are the USB port connection of the our Raspberry Pi. Raspberry Pi also has an external ultrasonic sensor. This is the HC-SR04 ultrasonic sensor used to measure the distance and avoid the obstacle in the front. And this is a camera which will be used for recognitions. And basically, the Raspberry Pi gonna send serial communication, which I will discuss later in the videos. So that's it for the hardware. Nothing much. I'm keeping things separate for testing purpose. So now we will go to the coding. So initially, to start off with, we like before I've said we have two processor, Raspberry Pi and the Arduino Mega. So we have to program each other separately. So I'll go through the Arduino Mega first. So the role of the Arduino in here is that it will read serial communication, which is serial output, from the Raspberry Pi to perform corresponding action. So this code file right here is the firmware from the library of this MBOT. So basically, the MBOT it has like its original Arduino code where it's gonna be running, like it will contain the I2C address of all of the components in here and all of the configuration, and that is the file right here, is the firmware file. So what I do, this file can be found on the internet. They publish the file so we can modify the code. So what I do is just go all the way to the bottom, because all these functions are like configuration and initialize function. Go all the way to the bottom. There will be a loop function. So I have erased the loop function and create my own loop function. So what's happened inside this loop function is, if the serial output has something in it, which means the Raspberry Pi is trying to sending something to the Arduino, which means the serial is available, and then it will read the serial and store in the variable C in here. So if C equal the letter F, which means in order to move forward, the Raspberry Pi will send the letter F to the Arduino. So if the Arduino receives a letter F, it will perform the function move forward. And then if the letter B, it will move backward. The same going with letter S for stopping, L for turning left, and R for turning right. And then I have these number 1, 2, 3, all of them are corresponding to like show. So this first one R right here, we have the parameters. We have numbers come in with serials like 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 12. So these number are the numbers of the LED in here. So we have 10 LEDs, and these are the, oh, we have 12 LEDs, so these are the 12 number corresponding to the LEDs. And then 0 to 550 are corresponding to the color channel of the light. It is in RGB. So right here, the value right here is G, which means this mode 1 is the green colors will be displayed. So mode 2 will be the red colors, and then mode 3 will be the blue colors, and then 4, this one right here, if you look closely, it is a rainbow light show. So it will go from like it will display a rainbow. And then mode 5 right here is also display the rainbow, but backward. Oh, I mean 4, mode 4 is the rainbow, and then turn the rainbow off. And then mode 5 is to turn everything off, the light, every light off. And H is for the buzzer. If the letter H is received, which means the buzzer will sound, which is the alarm, right? And now we will go to the function of the Raspberry Pi. This Raspberry Pi. The first thing, we'll go one by one from easy to complicated. The first thing is the movement control, as we have just talking about the Arduino. So we need to import the serial library to able to establish the serial communication. Then this is the line to specify the serial connection, where we'll connect to the specific port. We can list out the port in the terminal by typing ls list and then following by the USB. Oh, I mean the all of the port in the Pi. And then this is the baud rate. You can like customize this. It doesn't have to be this value. And then timeout to keep the function alive. Reset the buffer of the serial. And then here are the commands that are gonna be sent to the Arduino in binary. B in here stand for binary. So if it's in the letter F, then remember in the Arduino serial, if the Arduino right here, if the letter F is sent from the Pi, then the Arduino will move forward. So that's what's happening in here, in the movements here. If the letter F is sent, it stands for forward command. So right here I have defined a move forward function with so if the letter F, so if I call this function, it will write the forward function, which is it will send the letter F to the Arduino, making the robot to move forward. And in each of these functions, I have duration equal none, means that we can specify the duration. So say if we put duration equal 3, mean that the robot will move forward for 3 seconds. And then yeah, that's it. And the same thing going on with other functions like stop and move backward, turn left and turn right. And here's just the testing functions. Next thing, we have the light control, similar to the movement control. So just sending command to the Arduino, and then writing function to like easier to make the process done. So let's pick one. So let's pick this red light commander in here, in which I will do the same thing. Serial write the light red command in here. It is number 2. So it will send number 2 to the Arduino, and the Arduino can recognize that's number 2 is the red light show. So it's gonna turn all the red lights on. And duration is set if you want, like how long will the red light be. So if I set duration equal 3, it will turn off for 3. It will turn on for 3 seconds and then turn off. Right, and After that, I got a so this file is to sound the alarm. So the function is pretty simple. Just read from the serial and then send the letter H to the Arduino. The function I make is beep. I name it beep. So basically the function just send the letter H in here to the Arduino. And if the Arduino, back to the Arduino file, if the Arduino receives the letter H, like we see before, if it receives the letter H, and then the buzzer gonna sound. This code right here, I should erase it. Yes, and I just erased the code because it was not working, because I have my own ultrasonic sensor code in here. So this basically a GPIO read from the Raspberry Pi to read the value coming from this ultrasonic sensor, because this ultrasonic sensor is an external sensor, so it got jumper cables, jumper wires connect straight to the Raspberry Pi. So this is the code to read from that ultrasonic sensor. Okay, we read the distance, and then I will show you the face recognition. The main file here, it is search and rescue. So what happened in the search and rescue function, we'll go briefly, is that here is to load the information, and then I have the progress running showing to the output, and then here I initialize the camera, the webcam. Oh, and before we get into this, we have to train our own, I have to train on my own face data by using, and then I've got the encoding.pickles, which contain the face encoding data of my face. So I have the model file. I'll just call it out in the main file, search and rescue, and then it will be put in a while loop. So while searching, the camera will be activated, and then it will keep running, and then if the face is detect, this one in here saying that if land face location more than 0, which means one face is detect, more than one face is detected, more than 0, my bad. So that means there's a face detected in the frame, then the movement will be stopped, like movement control stop moving, duration 3, which means it will stop moving for 3 seconds, and then it will analyze the face. If the face is match in the face that has been trained, if it's matched, then it will take a picture, and then it will say that's the name of the people is found. So if my name is Paul, it will say Paul is found. Later I will run an example, and then the movement, it will stop moving, it will sound an alarm, and then it will light the green light. Then it will close the camera and send the message through the Telegram server. Oh. Right. And then we will cut the loop. It will break the loop by set searching to be false, because the loop is while searching. So if searching is false, mean that the loop will break. Otherwise, if the face is not matches, mean that it will keep going on. It keep looking. It will skip the face that it has detected, but it's not my face. And then in the so this code next, the code right here, telling that if there is no face detected, then the robot will just measure the distance and just keep moving forward. So if the distance is less than 50 centimeters, I mean that the distance is getting smaller, then the light will turn red for 0.5 seconds, and then it will move backward for 2 seconds, right? And then it will, like this one right here, it's a bit tricky. It will pick a random number from 1 to 2. So it will pick either 1 or 2, because if it pick 1, then it will turn left, and if it pick 2, it will turn right. Right, so that's how it is. So the direction is that will be assigned to a random value between 1 and 2. And then turn duration is the duration that we will turn. It will be in second. So it will be 1 to 3 seconds. So if the direction before one in here is 1, meaning it's mean that the robot will turn left in here. See, and if it's 2, then the robot will turn right. It's here. This code misidentification. Oh, it's because the code is too long, so it was jumping down there. See, okay, it's look better now. And so if the direction is 1, then the robot will turn left. Also, it will turn blue lights on. And then if the direction is 2, meaning it will turn right. And all of these are random, mean that I don't have control. I don't control any of these. So basically, they turn like with like they'll roll dice at either to turn left or right, and then the turn duration also will be random. It will be random from 1 to 3 seconds, and then it will be putting these parameters in here. So if this turn duration equal 2 and then direction equal 1, mean that you wanna turn left for 2 seconds. And then if the distance is more than 50 centimeters, mean that we're good. There's no obstacle in the front, and it just keep moving forward. So yeah, that is the search and rescue function, which is the main function. And now I will go through the user interface file. So this whole user interface is made with PyQt5, and these functions are basically just creating buttons on the Windows. I have my button image in here stored in the same directory. These are the buttons that I'm gonna use in the interface. So I basically just call it out, call a button, and then put the image on top of the button to make it look beautiful. And then just set the geometry, like set the position for the buttons. And then if the button is clicked, so say example, if the button up, it's clicked, it will connect to the function called move forward. And down here we will have a function move forward, in which it will actually move forward, just like the function in the movement control. Yeah, so so once again, I'll run the UI interface, and so you can see, you can see in here, these are the buttons, and if I click any of these, it will move accordingly, and if I click exit, it's gonna exit the program. So if the forward button is clicked, the robot will move forward. That's it, simply as that. And also the tricky thing right here, I believe, is how to display a small webcam view to integrate in the interface. So that is the quill label. So basically you create an empty quill label, and then you just fit a like use timer in here to record, like start a short 30 milliseconds video, and then you just update the frame in using Pixmap, update the frame into that quill label you have just created before. And scale it with the scale it to the correct ratios, right? And the last thing I believe is the Telegram message. So in order to send a message to the Telegram, we need to create a bot on Telegram first. So once you create the bot, you have a token and a user ID. So this library in here, it's just call out it will connect to our bots, and then I'll have function to send image, and then send location, and send the message and everything to the the Telegram chat server, and you can specify whoever you wanted to send. And the last thing is in the location. I forgot about the location. So the Raspberry Pi itself doesn't have any built-in GPS. So in order for me to retrieve the current location, what I do is just web scraping from this site right here. So I got a website here, it's called IP location. So by accessing this website, I can see my exact location through by my IP address, and then I'll just crawl the data there using HTML parser, and it'll crawl the latitude, longitude, country, region, and city, like all the current data, and for navigating, for for sending the message. So once we got the data, we'll return it into a list format, and then in the Telegram message again, I'll import the function IP location here, and then I'll call out the function to retrieve the location data. This line right here, which means I'll call out the IP location to retrieve the location and store it in location data. Then I'll just put all of the variable in the list to the message. So that's why you can see a message like this. So it's got the latitude, longitude, regions, states, Australia, country, all that is they're stored in this location data, and it's gonna be indexed later as this, and then put it into the big message to be sent. And yeah, I believe that's everything to describe about the code. And we will move on to some of the quick demos videos. I have demos my robots in the lab before, but I think it's better to try to demo it once again in here. And now I will have the robot to run the search and rescue function, which is the main function of this robot. Currently, I'm having the robot sitting on an obstacle, causing both of its wheels being lifted off the ground. So basically, these two tracks are above the ground, so we can visualize the movements better. The Raspberry Pi is connecting to a power source, and this is the screen of the edge of the Raspberry Pi. And then there's a USB cable that's connected straight into the Arduino Mega inside this MBOT. Right, and the way that I'm gonna conduct this demo for this function is first I will test out the ultrasonic sensor by placing random obstacle in front of the ultrasonic sensor, see if the behaviors of the robot change, and then I will put some not my face, the other people's face in front of the cameras to see if it's able to recognize that is the strangers, and then see its behavior accordingly. And then finally I'll jump into the front camera and see how it recognizes me. Right, and now let's get it working. I'm gonna execute the file, and we're gonna see the outputs on the terminal right here. It is saying the camera is booting and the rover's in action. Okay, so basically it is moving forward. we can see the trail that it is moving forward, and if we put an obstacle in front of the ultrasonic sensor, it's gonna detect the obstacle. So it's gonna detect the obstacle, it will stop, it will move backward and then change direction. I'm gonna demonstrate it again. Move backward, change direction, and then go forward. One last one again. So obstacle detect, move backward, change direction here, and then move forward. Yes, so that is the obstacle avoidance. One last time, obstacle ahead, red lights turn on, move backward, green light means that it is turning, and then it will move forward. Right, and we can now I'm gonna put this man's face in front of the camera. It's gonna detect as a stranger, and we're gonna see how the terminal is like, how its behavior is like. So it stops, meaning that it detects a face. In here it say face detects one, but the person is not the one that is looking for. So it keep on going again. It stop, face detect is one, but then it will stop, it will keep on going because this is not the person that it is looking for. Oh, I'm gonna show you the ultrasonic sensor in the terminal. I'm gonna put it right here and see what the terminal is like. There we go. So it got distance, it's below 30, so it's moved backward. And if a face show up, it will stop. It will stop right there. Then it will turn to, no, it will analyze the face. And then if it's not my face, then it's gonna keep going. So right now I'm gonna hop in. I'm gonna hop in to let it recognize me. And once it recognizes me, there will be a message sent into this chat. So this is the latest message where I demonstrate the robot inside the lab. But I'll hop in and see the new message coming up. I want to put it here. Okay. Right, so I've hopped in and it say that face detect is one and I am found. Paul is found, which is me. And the new message will be arrived shortly. There we go. That is me, and yes, that is my exact location at the moment. And if we click on the link, it will open to the map of the current place. There we go. I will not show. Okay, yep, there we go. So yeah, that is the search and rescue function. I have demonstrated this in the lab before, and I'm sorry I can't show you the robots on running on the floor at the moment. My desk is kind of small, but I think having it run on the like above the ground like this will also demonstrate the same purpose that we're aiming to. So this is going to be a demonstration of the UI control with the robot. So that is me on the live video right here. It's a live webcam and it's captured the live video and then display it in a small screen in the user interface. And then these buttons right here will control the robots to move in the corresponding directions. Then we got a little exit button right here to close the program. So right now we're gonna test the movement function with the UI. So I'm gonna press move forward, which means the robot's gonna move forward. I'm pressing it. Right, there was a little accident there, but it got back. And I'm sorry, it's just because the desk that I am displaying, the desk that I'm using to have the robots to run on is kind of small. So I've packed my stuff, but just trying to get the best one for you. So I'm gonna have it to run forward again. Clicking on the UI. Stop right there, good. And then move backward. Clicking the backward button. There we go. Move forward a little bit. Right, now I'm gonna make it turn left and right. So I'm gonna make it turn right first. And then turn to the opposite way. Oh, you can see the camera change as well. Like, put my hands here and you can see it on the webcam. There we go. Yep, that's how it works. Again, click on the right arrow button. Turn it right and turn left. This little button in the middle is the stop button. It's to make the robot stop its current movement. Move forward, backward, forward. Right, now turn. I'm gonna show you in the top view. Gonna turn right. Just move it a bit here. Then turn to the opposite way. There we go. There we go. I just got the good thing is that it got a mini live video right here, so you can just have this robot to enter like a manual program where you get to control it yourself to navigate through what to say, like complex obstacles or sort of that. Yep. So that's it for the UI demonstration.